Okay, we're going to do now Unit 7. And Unit 7 kind of brings together things that we did before and some graphing. So you might remember back in the day, earlier this year, we did these types of problems. X is greater than 3. So X can be a whole bunch of numbers, and we call that the solution set. So X could be 4, 5, 6, all the way to 15 million, and it keeps going after that. So X is everything above 3. X cannot be 3, but it's everything above 3. So could X be 3 in this case? No, but it's everything above 3. Okay. So 4, 5, 6, 7, all the way to infinity. All right. So in this case, if we were graphing this, then what we would do is we would find our X, and X is greater than 3. So here is the 3. So it's going to be everything above 3. So if you remember, what we would do is put a circle at 3, and then we have an arrow that goes this way, right? Now, let's say that instead of greater than, it said greater than or equal to. Well, if that was the case, instead of having a hole, we would have a filled in circle. Okay, so that's going to be the first example. Let me do one other example. Okay, so as you see, we flip the sign, and now it says X is less than 3. So here's 3, and it says X is less than 3. So that means X can be 2, X can be 1, X can be 0, X can be -1, all the way to infinity. To infinity and beyond, right? So what are we going to do? What are we going to do? What we're going to do is go to 3, and we're going to put a open circle, and we're going to stretch that arrow this way. All right. We have an open circle and it stretches that way. All right. Now, in this case, can we include 3 in this solution set? No, it's less than 3. So we can't include 3. We just cannot include 3 in the solution set because it's less than 3. But let's say we do this. Let's say we do this. We make it X is equal to or less than 3. Well, then everything changes. Then we can include 3 because X is equal to or less than 3. And so what we're going to do now is we're going to color all this and color in all this goodness. So now we have a closed circle, and we can include the number 3. So all of this is our solution set. This area here is our solution set. All of these numbers, 3, 2, 1, 0, -1, all the way down infinity in negative numbers. That's called our solution set. That solution set is X. X is the solution set. So it's not just one number, it's a bunch of numbers. Let me show you what I mean. All right, so this would be one number. This would be X equals 3. X is only 3. That's one number. But as soon as we have X is greater than, or X is less than or equal to, then it becomes a solution set. It's going to be a bunch of numbers. So instead of one number, it's a bunch of numbers. So the solution set is every number that works. So in this solution set, 3 works, right? 2 works, 1 works, 0 works, -1 works, -2 works, -3 works. All of these numbers work. That's the solution set. The solution set is every number that works. So what we're going to work on now, and what we just started working on with a reminder, is shading linear inequalities. We're shading linear inequalities. That's what we're going to be doing. So say to yourself, shading linear inequalities. Say it 3 times. Shading any shading linear shading. It's hard to say, but that's what we're going to be doing. Shading linear inequalities. So what we're going to do here is we're going to solve and graph the solution set. We need to solve and graph. So that's 2 different things. Solving is 1, graphing is 2. And what are we graphing? The solution set. That's what we're graphing. We're solving and graphing the solution set. So here we have 3x is greater than or less than -6. First of all, we need to solve for x. We need to solve for x. So remember this. This is important to remember. We're going to do inverse operations, which means to do the opposite. And you might be thinking, Mr. Varner, you're doing the most. Well, when you do the most, you get the most. All right, so we're going to do inverse operations, which means to do the opposite. So here we have 3x is greater than or equal to -6. 3x is really 3 times x. 3 times x is greater than or equal to -6. So what's the opposite, the inverse of this times operation? All right, the word operation, the operations are plus, minus, times, divide. What are the operations? Plus, minus, time, divide. Let's do the operations backwards. Divide, times, minus, plus. Well, what are the operations? Plus, minus, times, divide. Those are the operations. So we're going to do the inverse or the opposite. Okay, so the opposite of multiplication, which is this operation, is division. So now we're going to divide both numbers on both sides. Both sides. We're going to divide both sides. So 3 goes into 3 one time. That gives us 1. And I write my 1 small when they're being multiplied. So you actually don't need to even write the 1, but you can do that. All right, so now we have x or 1x or x, and 3 into -6 is -2. So now we know that if we get rid of this 1x, because that might throw you, that what we're going to graph is x is greater than or equal to -2. So what I'm doing now is I'm adding the numbers here to our graph because the second part said to graph it, right? So this is going to be -1. This is -2. This is -3. I can keep going because arrow means keep going. Okay, so x is greater than -2. So that means that the solution set for x, the solution set could be -1, it could be 0, it could be 1, it could be 2, it could be 3, all the way to infinity, right? Right? All the way to infinity. So what I'm going to do is go to the -2, which is right here, and I'm going to put a circle. And since the x, the solution set is x. Since the x is greater than or equal to, I'm going to put a dark circle, and I'm going to graph this way. All right, I'm going to graph this way. This way. Yep, I have a dark circle and I'm graphing this way. So I solved the inequality and I graphed the inequality, or I solved for x which is the solution set, and I graphed for x. Or I solved for the solution set and I graphed the solution set. That's how we did that. That's how it's done. Now, here's the interesting thing. The next part says, hey, you have to circle the values of x, and x is the solution set, all right, that are in the solution set, all the values of x. So it's -10. Well, -10 would be right over here, right? -10 would be further down here, and that's not going in that direction. So no, it can't be -10. Would it be -2? Well, let's see. X is greater than or equal to, so yes, it would be B. Would it be 0? Let's see. -2 is here, -1, 0 is in the solution set. All of this is the solution set. So yep. And we went to 4, but all of this is in the solution set. And I said that it carries on to infinity. So 10 would be in the solution set. So now we've answered A. Can I get an awa awa? And we answered B. All right, so let us move on. Okay, so I want you to look at what I've drawn. Well, what did you draw? What did you draw, Mr. Varner? I drew this. So draw this on your paper. You know, this is super important. Draw this on your paper. Right. I'm going to give you, what, 10 seconds to draw this. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, so here's the deal. Whenever you see a solid circle, you know it includes less than or equal to or greater than or equal to. And whenever you see a open circle, it's either less than or it's greater than. Here's the next level. This is why I asked you to draw this, because if you have a dark filled in circle, a filled in circle, and a straight line, a full straight line, it means the same thing. It means less than or equal to, or it means greater than or equal to. Now, if you have a dotted line, then your dotted line also means less than or equal to. So let this sit in your brain for a second. Full circle or a straight full line, less than or equal to, it has the equal sign at the bottom, or greater than or equal to has the equal sign at the bottom. Dotted line or open circle or dotted line, then it's going to be less than or greater than. Now, here's the thing. Okay? Let's add this. Greater than, if it's greater than, it goes up. If it's less than, it goes down. Okay? Greater than, it goes up. Less than, it goes down. So, okay. This is X is greater. This is X is greater than or equal to. Now, I'm hoping that you pick up on it. So if it says greater than or equal to, it's going to have a solid line. So that's greater than or equal to. If it has a dotted line, it's just greater than or less than. Well, this says greater than, and it has a dotted line. Okay. Now, if it says less than, then it would be X is less than, and it's a dotted line. And this would be X is less than or equal to. Now, if you noticed in this picture, I have it on this side. In this picture, I have it on this portion. In this one, it's up. You know, like Cardi B's song. If it's up, then it's up, then it's up, then it's up. Then this is it right here. And when it's greater than or equal to, it's up. It's up, it's up. Now, when it's less than, then it's down, down, down. When it's less than or equal to, it's down, down, down. And let me show you what I mean by, it's down, down, down. Okay, so, all right, this is greater than or equal to, so you're going to shade everything up. When it's up, then it's up. All right, you're going to shade up. And this is X is greater than or equal to, and you're going to shade up, and it's up, and it's up, and it's up, and it's up. You're shading there. But if it's less than, you're going to shade down, down, down. All right. If it's less than or equal to, you're less than or equal to, I got a little tongue tied. It's going to be down, down, down. So once again, if it's up, you're going to shade up, shade up. If it's down, you're going to shade down, shade down. So if it's greater, you're going to shade up, shade up. If it's less than, you're going to shade down, shade down. If it's greater than or equal to, you're going to shade up. Now, here's the thing. If you can just keep greater than up, less than down, if you get that, you're going to get 95% of these questions right. Now, I did something on here a little off, but we're not going to talk about it right now. We're not going to talk about it right now because I want you to get the concept. So 95% of the time, this is going to be perfectly right. So let's look at these problems, okay? Shade is directed. That says, let's just imagine, just imagine that there is a number here. So there's a letter, there's an X here, all right? X is less than or greater to, okay? Just imagine there's an X there, okay? Okay, so we're imagining, cool, cool, cool. That says X is less than is down. So less than, we're gonna shade down. And we're not gonna even hit the line. We're not gonna hit the line. This says X is less than or greater to. Okay, then we're gonna shade down. And here's the deal. We may hit the line this time because it says or equal to. But this one we didn't hit the line, this one we did. But both cases, X is less, all right? Now, oh, I put the X in the wrong spaces here and here. So let's do this. All right. Let's do this. We'll put we'll do it like that. So in this case, now we have whatever it is, X is greater than. So X is greater. So we're not going to hit the line, but we're going to blah, 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 go up. When it's up, when it's up, when it's up, then it's up. All right. And this one is or equal to. So we're going to hit the line. We're going to hit the line and we're going up. So whenever the solution set or X is the solution set. X is the solution set. So whenever the solution set is greater, you go up, then it's up, then it's up, then it's up, even if it's greater than or equal to. And if it's less, then you go down, down, down. Okay. So that should help you on 7.1 when we're dealing with shading slanted line. I'm not talking about dealing with shady people, but we're shading slanted lines.